Hello students, in this class I'm going to show you how to solve equations, multi-step equations. This is part 2. I have already uploaded a video where I have a few more examples on how to show how to solve some of these examples, some of these questions. Okay, um, to solve the first equation here, equation 1a, the first thing we're going to do is, there's many ways we could do this, maybe at least 2 ways. The first way I'm going to do this is by subtracting 4 from both sides. Or the way we're going to do it today is by subtracting 4 from both sides to leave this term t divided by -3 by itself. And of course 4 minus 8 minus 4 is 4. At this time what we're going to do is we're going to multiply both sides by -3 because we are dividing t by -3. The inverse operation would be to multiply by -3. And this allows us to divide -3 divided by -3, which is 1, and 1 times t is just t. And on the left side we get -12. So here's our answer. Please remember, if you want to check the answer, you could substitute that t, that 12, back, and then show that the left side is equal to the right side. You could also do it mentally. The justification of these steps here, if you just go from this step to the the first step was to subtract 4 from both sides. So subtract 4 from both sides. The next thing we did was multiply everything by -3, or multiply both sides by -3. And then finally we just simplified. If you needed to justify your steps, that's the way you would write it down. Okay, so part B is very similar. We're going to start by subtracting 5 from both sides to leave that term that has a variable by itself. Remember, both sides means both sides of the equal sign right here, both sides of that dotted line. And so on the left side, we're going to end up with the p over -2 equals 4. And if we multiply both sides by -2 at this point, that'll cancel the division by -2. And p equals -8. There you go. Next, we're going to solve this equation. Notice how on the right side of this equation we have many terms, and we could combine like terms to make it easier. So that will be the first step, to combine like terms. So 10y minus 3y makes 7y. We didn't do anything 35 to -35 or 28. The next thing you would do is you would try to get rid of that -35 by adding 35 to both sides. And you're going to get a total of 7y on the right side and 63 on the left side. To undo that multiplication by 7, next we're going to divide both sides by 7. And this will give us y on the right side, because 7 divided by 7 is 1. And 9 on the left side, because 63 divided by 7 is 9. Again, you could check the answer by substituting back into your original equation. Okay, the next one is very similar. We're going to combine like terms on the left side. 11t and 3t adds up to 14t. We didn't do anything to that -6 or the 30, -30. Again, look at this, the nature of this equation is we're going to get rid of that -6 by adding 6 to both sides. And 14t would be equal to -24. And dividing both sides by 14 here is going to give us t equal to -24 over 14. Please note that both of these numbers, 24 and 14, are divisible by 2. And so it'll give us a -12, because 24 divided by 2 is 12, divided by 7. And that would be the simplified answer in fraction form. The next two problems are a little different, because the first thing we have to do here is distribute that inside the parentheses. In other words, we're trying to get rid of the parentheses. So we do that by copying that down to -7 I'm sorry, copying the 12 down. And then here, distribute means to multiply. This right here means to multiplication right here. So negative 5 times 3 makes negative 15. Negative 5 times 2, distributed to a 2 as well, makes negative 10. And then we have something on the left side that we have seen before where we combine like terms. Negative 10 and 12 add up to 2. And if we go ahead and subtract 2 from both sides to, start isolating the r, we get that r, you can do it mentally, what number times negative 15 makes positive 15? Well, you know that r has to be negative 1. But if you wanted to show the steps, you would divide both sides by negative 15. And there you go. Now we know that negative 15 divided by negative 15 is 1. And negative 15 divided by positive 15 divided by negative 15 is negative 1, giving us our answer here. So example 1F, part F is the same thing. We're going to do that distributive property or that distribution twice. On the first one, we're going to get 2 times W, which is 2W. 2 times negative 7, which is negative 14. Negative 3 times 5, which is negative 15. And negative times a negative makes positive. 3W equals 0. Notice how on the left side we have quite a few terms, like terms that we could combine. 2W and 3W makes a total of 5. And then negative 14 and negative 15 makes negative 29. And that is equal to 0. If we're going to solve for W, we need to add 29 to both sides. And dividing both sides by 5 gives us our answer. Now 25 and 9 don't have anything in common. They don't divide by the same numbers, so we leave it like that. That's our final answer. Okay. Example number 2, we're going to do something similar to solve it. We're going to set up an equation, and then we're going to solve it by using the strategy or strategies that we used in the previous examples. But first we have to write down an equation. So it says here you can represent an odd integer by the expression 2n plus 1. So if we're gonna let one integer, or first integer, odd integer I should say, we're gonna call it 2n plus 1. So if you read the question, we're supposed to figure out what 3 consecutive odd integers have a sum of 63. So I'm going to let my first integer equal to 2n plus 1 because they told us that that's the way we could write an integer. Next, I'm going to try to figure out what the second integer or odd integer is. Integer. Well, let's say, for example, that our integer was 7 to start with. Let's just say this. If we wanted to get the next consecutive one, we would have to add 2 to it to get 9. And if we wanted to get the next one, we would have to add 2 to the previous one or 4 to the prior one. So it would be 11. So notice again how this is plus 2. And then if we wanted to go from here to here, that will be plus 4. So if this is our first integer, 2n plus 1, then the second integer would be 2n plus 1 plus 2. And then the third integer would be 2n plus 1 plus 4, or 2n plus 1 plus 2 plus 2. Well, let me erase this. If you want to simplify, before we put it into an equation, this really becomes 2n plus 3, and this becomes 2n plus 5. And so these are our 3 integers. So now what we could do is we could set up an equation because we want to find them. In order for us to, we need to find 3 integers that add up to 63. This is giving me a hard time. And so now we know then that 2n plus 1 plus 2n plus 3 plus 2n plus 5 are supposed to add up to 63. Again, notice that this is our first integer plus the second one plus the third one. And we're setting it equal to 63 because we want them to add to 63. And so the way to solve this equation is simply by combining like terms on the left side, like we did in the previous examples. Notice the like terms here, I'm going to do with, let's say, red. 2n plus 2n plus 2n makes a total of 6n. And let me do this with green. 1n, I'm sorry, just 1 plus 3 plus 5, that makes a total of 9. And we still have that 63 on the right side. So it's solving for n. It's gonna, tell us to subtract 9 from both sides first. 63 minus 9 is 54. And dividing both sides by 6, like we did in the previous examples, this gives us n equals 9. Now, we always make sense of our answers. If they wanted us to find out what n was, we are done, but they didn't ask us to find n. They wanted to find 3 consecutive odd integers that add up to 63. So now that we know that n equals 9, we're going to substitute this n back into this here, and here to figure out the first integer. So 2 times 9 plus 1 equals 18 plus 1 is 19. So the first integer we needed to find was 19. And you could substitute and add, or you can just figure out that the next odd integer would be 21, and the next one would be 23. But you could check again. Look, 2 times 9 plus 5. 2 times 9 is 18, and 18 plus 5 makes 23. 2 times 9 plus 3 equals 18 plus 3, which is 21. So our 3 consecutive odd integers are 19, 21, and 23. And if you add them up, you could verify that they indeed actually add up to 63. And so here's a word problem that we could solve by setting up an equation and then use the strategies that we used up here to solve these problems. Please feel free to watch this video again if you need to, repeat it, slow it down, and copy it on a piece of paper as part of your notes. See you next time.